So, back to the diagram, we talk about reliable cyber recovery, and as a recovery pillar, it's not just about restoring data. It involves planning, validating, testing, uh, even evidence gathering. So, as we talked about some of these components, we have chunks of the product that kind of facilitate these things. So this is much more than just, restoring data. And obviously customers are looking to do this quickly and at scale using, run books and, other components as we have to interoperate between, other applications. But customers are also looking for flexibility, right? We have workloads in the cloud, we have workloads on-prem, they need portability between the two, and they need it to be simple, right? Because admins are not always wearing every single hat in the environment, and there may be some expertise over in Azure or GCP or OCI that maybe some of the traditional folks that understand on-prem, it may be foreign to them. So, having a simplified way to do all that is really important, especially, if we don't have, real ironed out plans on how we're going to recover when, things happen and there's a significant impact. Now, in addition to that, when we look at it from a surgical level, last known good versions of the files, malware-free recoveries, these are things that should be automatically curated for the users, right? They shouldn't have to, do all these step restores and have to guess on, where the good data is. So, a lot of these components have to come all together in order for us to have like that ultimate solution that we provide our customers. Now, when we look at the stat that's on the screen from ESG, you can see that there's a pretty low level of confidence in folks, having the ability to recover their data. And I think there's a couple things that kind of play into that, and I want to unpack that a little bit. So, I think we're all familiar, and we've gone through a lot of the, scenarios on how threat behaviors kind of enter the environment, right? There's phishing, and we talked about exploits and, LOL bins, and, things continue to become sophisticated and they go undetected, right? And as we were just talking about, there's this constant refactoring of, how we're going to do things as threats evolve. Not to forget the stuff that we did, because it may still be relevant. And I think there's been some old threats that are coming back into fashion. But, making things just better so that it becomes more comprehensive. And, Dave and Steve covered, our multifaceted approach to staying ahead of, these advanced threats and exposing them as quickly as possible, because at the end of the day, we don't want to have to do mass recovery. And surgical recovery allows us to just be better, faster, and more cost effective. So, getting to that point is really what our customers have been, asking us for. And when threats do start to propagate through the environment, they ask us these two fundamental questions: is my data clean, and can I recover quickly? So it's really important that, we answer those questions. And if my data is not clean, it's not just I can't get my data back, but, I run the potential risk of reinfection. So there's these lot of things that are kind of, playing against us in this scenario. So, customers want to make sure that they can get their data back quickly, and of course that it's clean. And, like I said before, they've deployed traditional tactics of, hey, I'll just do a whole bunch of step restores. Let me keep restoring it back to a point of, maybe there is no infection, and, we're constantly doing scans and then just keep stepping backwards. There's clean room recoveries, which also take time. So a lot of those have kind of fall out of fashion. Sure, there's use cases that they should use them, but again, lots of time spent doing those things, and, a lot of costs associated to them. So, at the end of the day, I want my data clean and I want it now. And, on the flip side of that, that's just to get away from, when threats propagate. Customers are also looking for the flexibility, because when we need to do forensics, we need to bring back, these components into that particular state so that we can figure out how these things penetrated the environment and how we're going to prevent it moving forward. So I think that also talks about, one of the other additional challenges on why customers don't have real confidence in, recovering their data. So, when we talk about amplifying the cyber response, to me, I think about this complex matrix of tooling and personas across. And, Dave and Steve kind of touched upon some of those. And we commonly see both sides of this spectrum as extremes, and they're working against each other. So you have like these gray area handoffs where, not everyone in the mix is fully understood their responsibility. So, with them not owning it, we're going back and forth, and you're seeing, delays being introduced. And then you're seeing like territorial lines, like the complete opposite side of the spectrum, where this is my role in this is my only role in this, and I have to get this done, and all the other things downstream can't be done, and that causes bottlenecks, and things get jammed up in red tape. Now I know Dave glanced over it in his XOR video, but just taking ownership of the ticket inside XOR, provides that responsibility and awareness that he as a user is going to action on those things. And what he didn't show is even on the Commvault side, tagging in things that we can do on these assets allow us to have that visibility across multiple personas. So even though we may have a SecOps guy sitting in XOR, tagging things and taking responsibility, the automation can be tagging things on the Commvault side so that the Commvault admin knows that this thing is kind of in progress and he doesn't have to do anything. So, when we have all these multiple personas, having that visibility and awareness of what's happening can all happen in this automated fashion. So, bringing this upper level awareness, is really key for us to be able to respond accurately and quickly. And, these are the things that I think certainly play into the customer's confidence. But even when we've surveyed our internal, customers, they even admitted to like not even having recovery plans. And a lot of that has to do with the tooling and the multiple personas involved. And, one of my pet peeves that I always say is, hope is not a plan. So, people have to start to rely on the tooling, being able to have this visibility and awareness and have the right tool for the right job, in place. So, Commvault helps our customers kind of simplify that response. And I'm going to show you how we do that in just a second. So I think you mentioned before, we talked about, Commvault Threat Scan, and, reducing the blast radius, minimizing the impact kind of helps Threat Scan do what it really needs to do. And that is, simplify and optimize how we look at the data to make sure that not only are we not putting back threats, but we're also identifying files that may have been compromised or the entropy scores are high, or, any of these types of behaviors that to us becomes, hey, you might want to inspect this and do a deeper level scan. So, these are the types of things that continue to raise that level of awareness on those particular, on a file level, like a deep scan into the files. And what's good about Threat Scan is it allows us to actually take a very surgical approach. And when we take surgical approaches, it allows us to do things quickly. So instead of folks, doing the step restores or just saying, hey, you know what? I know the machine wasn't compromised 5 days ago. Let's just roll the entire machine back to 5 days, and you have, 5 days worth of data loss that might have been on the machine. Those just aren't suitable options anymore. So, these tools allow us to really take a surgical approach to these things. Again, we could do it on a surgical level and we could do it on a bulk level. And I'll kind of show this as I get into the demo for Threat Scan. Now, Dave was talking about immutability before, right? And our storage is immutable. So, if we're going to be removing threats from an environment, how do we maintain immutability on the storage? So forever, Commvault has always worked on a 4D index. And within our index, it allows us to actually flag the threats and flag anomalies and all these things so that when we actually go to the point of doing a restore, we can actually just not recover those things unless we absolutely want to. So again, we talked about flexibility not too long ago. The index is really what powers our ability to have that flexibility. So with Threat Scan, if we find some threats, we will automatically exclude them from the recovery. So as my end users or my admins or performing recoveries, they're automatically excluded and we don't have to worry about reinfection. On the flip side, because we're using the index to flag anomalies, once we have to do forensic scan, we can absolutely force the product to return the compromised machine to that particular state in an isolated environment. And we'll talk about how we orchestrate that through auto recovery. But we can bring that machine back so that the forensics team can go do their necessary actions. So again, I know I'm up against time, so let me just get into the demo. All right, so this is just a Windows file server. What I'll do is we were doing some LLM work, David and I, so we have some some PDFs. I'll just show you that this is the live file system, and we have some good files that are operating on the machine. And then obviously we'll use these exact same examples as threats become propagated. So just to validate that on the live file system, everything's all good. So we're going to run our mock ransomware. This is going to add some extensions. It's going to encrypt a handful of blocks on the file, so it quickly sweeps through our environment. We'll start to see that
So it is doing
extension.
It is doing partial file. Yeah. So with a symmetric key that it then generates a private key, public key for at the end. Is that so? You end up with a partially encrypted, symmetrically.
Partially encrypted.
Yeah.
Correct.
Okay.
Yeah. So as Dave was mentioning, we were talking about XOR. Steve was talking about Splunk. We have interoperability with, Sentinel. So we have a lot of different integrations. So, in this particular example, we're using Splunk, and sure, we could have, Phantom playbooks, and I'm probably dating myself. I know they call it Splunk SOAR now, but this can absolutely drive any of the post actions that we want, similar to what we go with XOR. So right now, what we're showing is that Splunk is ingesting our anomaly alerts. So we're using our file activity webhook, and there's two different things. We saw that there was a bunch of files created, and there was a bunch of files renamed. So usually we'll see the file creation based on your ransomware note. You'll see the ransomware note ends up getting placed across all of the particular folders, and then obviously modified because a lot of the files were all modified through the threat. We can see that here. And then obviously this gets bubbled up and we can action on it appropriately. All right. And now back into the Commvault UI. Using Command Center, we can go quickly to Security IQ. And again, Dave was talking about how we kind of use Security IQ as that top level way to inspect what's going on in the environment. We can see that we have a file activity anomaly. And again, we have different anomalies, and we'll see that in just a second. But this particular one is about the file activity on the live file system. So we can see that my particular machine had 3,300 files that were affected. And what we're going to do is we're going to tell the product to use the deep level scan. And it'll start to scan through the backups so that we can start to look at, how my backups have been compromised and might be compromised within the environment. And like I was saying before, I know that sped through, but having that awareness on both sides of the fence is really important as we have multiple personas working on these things. So, when Dave was showing the XOR side, he assigned the ticket to himself. He tagged it that he was working on it. And then on the Commvault side, again, we can do it through automation, but now that he's actually actioning on it as the Commvault admin, he can set a tag that he's running threat scan, and we're analyzing the content before we actually do any actions. All right, so the job runs. Now you can actually see that not only do I have my file activity anomaly, but we also see file data, and we also see threat analysis. We'll start to unpack that, and you can see I have nearly 12,000 files that are affected. So the deep analysis started to expose further things that are happening in the environment now that I have a deep scan. So if you think about the life cycle of what just happened, we have live file system anomalies telling us, hey, there's something going on the machine. And then we use our deeper analysis to say, okay, we know something happened on the machine, but what is that something? This is what gives us those additional insights, and we'll kind of go through those piece by piece. So in our threat analysis is purely about threats. So there's two separate things coming into play here. We have our threats, and then we actually have our suspicious files. So now the first thing we're doing is we're looking at the threats. So you can see that we have some detection time. And again, this is happening across multiple backups. So maybe I had a threat that was, slow moving, and now we're actually detecting all the different areas and what they actually are. So, we're using a leading SDK to actually do the detection here. And what's most important about, us detecting this criteria is that we will automatically exclude this from being recovered, right? There's no other further action that needs to be taken. If we detect it, we will not recover this as part of, a general recovery operation. So if I have end users that maybe this was an end user machine or an endpoint machine, and he has access to recover his own data, there will be no threats that he would be exposed to reintroduce threats into the environment, once it's clean, obviously. And then the second piece is the suspicious files. So again, we talked about this a little bit before during David's section. We talked about, significant changes inside the file, of the file, and then, we have an entropy score that we produce that we can expect on a file by file level. we'll kind of take a look at that. And there's other, file types and other things so that you can kind of see the behavior of what's happening with the product. So here we can see that, we have two separate backup IDs that show that, at some point the file had no suspicious characteristics. And then, a subsequent backup that we ran a little bit later in the day, now we see that that was marked suspicious. So we can take a look at those two and validate that behavior. So when we look at the original one, you can see it opened up the file just like we did on the live file system. And this is the same generative AI PDF that we showed before on the live file system. This substantiated view is coming directly from the backup. So this isn't coming from the live file system. And obviously we know that the live file system was compromised. So this gets right out of our backup. And you can see that there's several bits of information about, what's the access control, who owns it, where did it come from, and was it marked corrupt, and is the status safe? So from here, I could just do the preview. I could also download it, say I wanted to give it back to my user. Now, we also clicked on the compromised file, and I know that's through, but this is the actual other file that we marked as suspicious. So we haven't marked it compromised or anything else yet, but it's been marked suspicious. And it says, compared to the previous version, this was marked suspicious because there's been significant changes to the file and it has a high entropy score. So we know that some threat had actioned on this appropriate at some standpoint. So this kind of gives us a good insight. And then the fact that we can't view it, through the backup, even further tells us that there's something compromised about the file. So we kind of use these as all types of indicators on, hey, this threat actually did do something to a significant amount of my files, and now I can actually action on it. So we can download the file if you want to further verify that the live file is bad. We can mark it safe. Like if this did show up, we can say, hey, maybe this was an anomaly of sorts where, yep, it was high entropy, but someone went into a text file and changed a whole bunch of stuff in it. So maybe the entropy score went really high. Or we can mark it corrupt, which would again flag this in the index as, hey, this file's corrupt, and then automatically allow us to restore last known good. So again, we can see that there's several facets that we can action on, and we can do that level of inspection. Now, we've done that level of inspection on the file. We marked it corrupt. And if we went to go do a restore, it would recover the last known good. Now, again, that was on a file basis, and we could apply, once we have a threat, we can make sure that if we have a single threat and we say, hey, this file is corrupt, we can do it on a surgical level, as I mentioned before, like this is just a single file, or we can say, all the files that we've marked in this particular capacity is corrupt, so don't recover them. So as I've been talking, we actually performed the in-place recovery. We didn't have to do any other operations, and we recovered the last known good version of that entire folder. So we put all that data back appropriately. So again, it provides us with a surgical path to recover the data. And then as we continue, we can continue to build out on a file level, on a folder level, or even on a machine level, we can recover the data. This again allows us to seek not only threats, but also compromised files. And again, doing that level of inspection on the compromised files is really important so that, we can flag, things that are anomalous that are truly threats, impacted them, or maybe there was, some behavior on the machine that, it threw the entropy score through the roof, and, we can mark it safe so that, for subsequently that file wouldn't be, flagged as anomalous. So that was a very surgical approach to recovery. And then there may be a need where we have to do mass recovery or orchestrated recovery, where the ordering and things is really important. So I know I'm probably very much at time, but I'll try to breeze through this as fast as possible. So as you know, with Commvault, our breadth and depth is unparalleled, right? We can take virtual machines and transform them into, cloud compute instances. We can take on-prem SQL databases and refactor them into the cloud, into PaaS. So, workload portability, workload supportability, and being able to kind of transform workloads and move them, to the cloud, back on-prem, onto hybrid, onto edge. All of those things are, fair game for us. So when you think about recovering an environment, it's very comprehensive in addition to all the other things that we kind of talked about today. And then we have the concept of really any SLA. So with auto recovery, we can do data protection and replication on a continuous level, on a scheduled level, or even periodic. So a very robust set of tooling that we have. And all the features that we kind of talked about today all interplay with auto recovery. So nothing's really excluded. When we need to do mass recovery, we can still have all those surgical operations where we're running threat scans and file data analysis to kind of provide us with a good test bed to recover safely. So a lot of this is driven by, our plans, and these constructs that we have in the product allow us to continually auto tune. So we talked about some machine learning and time series based ML that we have for detecting anomalies. We use a lot of that to make sure that we're adhering to RPOs and RTOs too. So a lot of that information is constantly tuning in the environment so that we can meet these stringent things, whatever we've set them. And again, being able to, transform these workloads and move them in and out wherever we need to, is also fair game, and we can do it, quickly, securely, and at scale. And, one of the other things that David had mentioned before about the recovery validation when we were talking about the database scenario in the table encryption, the recovery framework, the recovery validation framework allows us to kind of do that next level inspection. So, we can bring the machine and the database back to a certain point, and we have an open framework where you can kind of do those advanced level validations for your DBAs just to make sure we can constantly do that. And, why I continually talk about these capabilities is because, again, we've seen users not wanting to constantly test and validate DR and recovering from these scenarios. So auto recovery gives us a good test bed to do it, but also our platform provides us with, a very cost optimized architecture where we don't need to have long running instances running in the cloud. We don't have to use, expensive Windows and Intel based instances. We could use ARM and open source Linux to kind of run all these operations. We can take advantage of spot instances. David was talking about power management. So, when you think about long running instances and all these other things kind of in the cloud, we take a very cost optimized approach to, not only being able to do DR tests, but also, recovering when we have threats that proliferate or even disasters. So really important set of tooling that it's not always about recovering at all costs. There's a lot of ways that we could recover at speed, at scale, securely, regardless of the threat vector or problem that has happened, and do it in a very cost-effective manner that I think is, unparalleled, especially in our particular space. And again, we talked about forensics and, we talked about, secure recovery. So, recovering at scale is certainly baked into the DNA of the product. And, for all the cloud natives, if I didn't run out of time, I would certainly start talking about how we could do this, in the cloud using infrastructure as code and CloudFormation and ARM templates. But just know that, the flexibility of the product allows you to kind of use the right tool for the right job. And if you're more familiar with, not needing maybe an orchestration tool to do things in order, you could absolutely use our product to do brute force methods, in the cloud, in AWS, using CloudFormation or Terraform or whatever to kind of just do something as absolutely fast as possible and get your users up and running with the least amount of cost.